In this video, I'm going to show you how to assemble the Lego lightsabers I designed. There's two versions. There's the simple one where you just use a 12-volt power outlet and power from the wall. And there's a design where I utilize these Milwaukee M12 batteries. I have a couple of these work lights. They're awesome, handy, but kind of expensive. And so I was thinking, oh, maybe I'd try to use the 3D printer to add to my collection there. If you like the video, please give it a thumbs up. Look in the doobly-doo for links to the parts I used and to Printables where all the files can be downloaded for free. We've got a little mise en place here. All the 3D printed parts have been prepped off the printer. We have purchase components. You got a LED bulb. This one happens to be color changing. That's not strictly necessary, but it's the fun way to go about it. You have a bulb socket. Those can be purchased in conjunction. I can't speak for other bulbs. I'm not even sure what the lumens or wattage is on this one, but no problems with the 12-volt power supply that I was able to find old from another device. You have tools needed. Deburr tool for cleaning the prints, pretty handy. You really don't want any sharp edges wherever you're gonna have the wires running through. Some chafing there could cause you issues down the road. And I guess screwdriver's not really necessary, but I used it to help break off some supports. My bulb socket happened to come with the ends pre-stripped, so it's just a matter of quickly twisting the wires. And if you're not familiar, this is a Wago style, although it's an off-brand lever connector, so I can insert the end of one of the leads into the first connector, click it in place, second lead into the second connector, click it in place, give it a quick tug test, make sure you got good contact. And there's a little trick on these. Since you have clear plastic, it's pretty tough to see, but you can actually see in there, if I can get the camera to focus, see in there and see that you're pinching on metal and not insulation. The rest of it, pretty simple. You're gonna start by feeding your power wires through the hole in the bottom of, I guess I'm calling this the base or the bottom. You can pull that through, make sure we have enough slack. Get it through the whole device. Make sure that when you prep the print, you clean out the inside of these notches. It's kind of a twist lock action. So you're gonna feed the wire all the way through. And you can shove this thing down in place. Just make sure you match up the tabs, slide it, and this one's pretty rough, but turn to lock it in place. Next, we can grab either end of the power wires and connect them to one each of the lever connectors. So always do that tug test, make sure it's well inserted. These happen to have some ferrules on the end. They don't work very well with this type of connector. I could always strip them off, but if you get it inserted well enough, they tend to stay. Now, if this was going to be sitting on your desk and you got kids or something, you might want to either tie a knot in this or add a zip tie somewhere as a strain relief. So I'm just gonna make a little loop. And we'll add a zip tie to this so that, for whatever reason, if you gave these wires a big tug or the lamp fell off your desk, the wires couldn't be pulled out of the lever connector. Find a zip tie. Secure that in place. Next, we have the bulb socket. Shove that through, and at this point you can connect your bulb. If you want to give this a test at this point, make sure everything's working, you can, or you can shove it together and it's not too hard to take this thing apart if you have any issues. Shove your wires back in the hole. Shove your bulb adapter down in there, make sure it's seated. Push all your wires down in and seat the bulb. At this point, you can pull out your excess. There's a little channel in there. You could put some hot glue if you wanted to keep the cable in check. And now it's a matter of some more of those twist locks. So we're gonna line up the zip tie poking through. We're going to line up the slots, push it in place, and twist to lock. Last step, adding the vase mode printed clear plastic tube. It's just a press fit, presses in place, and now you have a completed lightsaber light. We got a flashlight version. You can print a different size vase top and make it a little bit more usable as a flashlight, or go with the same color changing action. So this one has a Milwaukee M12 battery inside. Use a battery adapter so that you could plug and play off the shelf with Milwaukee or off-brand batteries if you so choose. And we can break this one down real quick to see how that's done. Everything is twist lock. This uses a majority of the same parts as the other build. The main difference here being the handle tube. The base doesn't have the hole in the bottom. The Milwaukee battery adapter that I bought, which should be linked in the description, came with a switch. And then the first go round, I built this thing and I didn't have any low voltage cutoff. From what I can tell, the Milwaukee M12 batteries don't have that built in, so you need to monitor that, otherwise you could draw the current down. I don't know if that's strictly necessary with like an LED type application, but I added that to this one. So there's a low voltage cutoff board. Basically you take the power out of the adapter, one end should be run up to the switch, and I ended up cutting that prematurely there. So I had to run it up to the switch and then back down into the input side of the board, and the output side of the board will go to your bulb socket. I'll link a video on how to set this up, but basically you just have to set the voltage cutoff so that when the battery drops below, let's say 10 volts, it'll turn off the system and not keep drawing the battery down. The remote and everything still works. There's a little bit of a trick to getting it together. You can see there's a hard stop down in the tube. That's what this adapter actually pushes up against. And then I did add a little dovetail feature so that when you assemble this thing, it doesn't want to fall back apart every time you go to pop the battery out. Otherwise there's nothing holding this in place. So you can either hot glue or super glue this thing down in. I found that it stays in pretty well just with a little bit of friction fit. The layer lines kind of act like a one-way stop, so you can kind of shove that down in place, shove the battery in, and of course pops right out. Alright, so I got that all glued in off camera. Put our battery back in place. We can then align the button with a slot. There's a little feature on there that needs to locate in a slot down there. I have found the best way to do that is kind of line it up and push it in place. And then we can connect up our light. That just pushes onto the socket, and then this notch actually comes into play on this one. That notch holds the switch in place, and then you might have to fuss with some wires to get them out of the way, but the action of putting the top on will actually hold this piece in place. Get that in place and push down good, twist to lock, and now that's positively affixed. Same deal with this thing, and now we can shove it back together, turn it on. There's a little delay because of that voltage cutoff board, but remote still works. All right, outside, give a little bit of an idea of how much light this thing throws. It's enough to work. It's kind of nice because it's a soft light, so you can kind of look at it and not get blinded. What do you think, Skip?